Hello, how y'all doing today? My name is Bernie Thompson, and today we're here to take a look at this little 2007 Acura TSX. This little Acura has a vibration, and this little Acura has been to a lot of shops. It's been to several shops, a tire shop, and the dealership. So far, all the tires have been replaced and balanced on this vehicle. The entire front end has been rebuilt, all the ball joints, bushings. Both axles have been replaced and one of the axle stubs have been replaced. The car still vibrates. So I don't want to have the same problem that these guys have had where they're hanging parts and it doesn't fix the vibration. So the first thing I want to do is put a vibration analyzer on the car. So I'm going to use my ATS, Intelligent Vibration Analyzer. The shop doesn't have a lift available where I can get all four sensors put on this vehicle right now. So I'm going to cut a corner and it's going to hurt me, but I'm going to just take one sensor and put it on the seat rail. Now we're going to go ahead and we're going to get the vibration by the seat rail, and that's the same as everyone else's NVH on the market today. They only use a sensor, and so that's what we're going to do. We're going to see what data we can collect with one sensor. Let's get that on the seat rail. Okay, so I've got one sensor on the seat rail, so let's go ahead and set the tool up. So we're going to leave it in front wheel drive because that is what this is, and we can see that in the setup in the main window we can see that it's a transaxle, and that is what I have, so I've got the right vehicle selected. Now we're going to come over and we're going to pick one sensor, and I've got it on the driver's seat. So now I've got this set up. Now you got to have the tire size set up. Okay, 215, 5017 is my tire size. They're all the same size, and I double checked that they're all the same, so I'm okay. Now, I don't know what the ring and pinion is in this, so I'm going to let my machine calculate it. This has an algorithm that will calculate this ring and pinion for me. We need to get on a highway and we need to go 60 miles an hour, and that's okay because this vibration is only at 60 miles an hour apparently anyway. So now let's get on the highway and let it figure out that for me. Can we get it? Okay, so we are on the highway now. We're going 60 miles an hour, and it found the ring and pinion. So we're good to go now. Now we're going to go up here where the pavement is smoother. It's always best to be on smooth pavement, guys. It will find the problem when it's not smooth, but we're best. Okay, we're on smooth pavement, so we want to start. Sensitivity. Okay guys, we found it. It's a wheel speed. It's going at a wheel speed. See right here? Okay, so we got a problem with one of the wheels. And we can see it's a good vibration. We're in the red, okay? So we got a good vibration. I can feel the vibration. So I'm going to back out of the throttle here, and it's barely vibrating there. It's not very bad. This is load sensitive. I can see that right away. So I'm floating the car right now. I'm at just a constant light throttle. And we can see that I can feel the vibration, but it's light. Now if I start to get into the throttle, okay, I can definitely feel it. So this has something to do with load. Where I'm loading it, I'm feeling it. Okay, now what does that do for me, guys? I should have waited for the lift because now I'm up the highway and I've burned another 20 minutes. And all I know is one of the wheels has a problem. Well, the technicians that have been working on it know that it's at wheel speed. I can tell you that by just driving the car and the feel of it. I don't know which wheel. What I need to know is which wheel it is. Not that it's just at a wheel speed. Like I say, the guys that have been working on this car so far, they know it's a wheel. They replaced all the tires. They've replaced the axles. They've replaced the stub. So what are we going to do? Go replace the other pieces that haven't been replaced? I don't know about that, guys. What I need to do is I need all 4 sensors on this car where I can actually figure out where that vibration is being emitted from. I can feel it, and the whole car is shaking for sure. I can feel the whole car shake. It's hard for me to tell exactly where that vibration is coming from right now. I know it's at wheel speed because I can feel that just by looking at the tach, driving the car. I can feel that. But that's not going to help me fix this car. They've already been working on it. They've already put a bunch of parts on this car. Now, I don't want to put any more parts on the car to find out I didn't fix the vibration. I need the right tool, and that's going to be multi-sensor vibration analyzer, so I don't make a mistake. So I need to go back to the shop and get a lift. Okay guys, I got a lift, so we're going to go ahead and get the sensors set up on this car so we can accurately diagnose this car. We can't continue to guess. We've already seen what guesses got. 4 tires, 2 axles, an axle stub, and the car still vibrates. And these are good shops that are working in a dealership that did this to this car. We have to diagnose the car. That means we need the right equipment. The right equipment is putting a sensor on each corner of the car and having a program to where it triangulates the vibration, and it helps me know exactly where the vibration is being emitted from. That's what we need. So let's go ahead and get this set up on this vehicle. Okay guys, the first one, we have 1 sensor for each corner of the car. We're going to take the left front, driver front. We're going to take the cable that matches the yellow, and we're going to get this installed on the car. Okay, now there's a magnet inside this sensor, so it's easy installation. And this is a steel arm, so it's not aluminum, so it will stick directly to it. Then we just take these cable magnets and we just route this right over inside the car. Okay guys, once you bring the cables and you get the magnets and we bring it out at the end, we want to tape this down, and what I want to use is painter's tape, and there'll be no residue on the paint. Just wipe it down with water and tape it down so there's no dirt on there. And then we can do it 2 ways. I prefer just taking them under the door jamb. Now always look at the door jamb and make sure that there's a good rubber insulation to where it's not going to pinch and break the cable. Now the other way I can do this as well is what I did on the back. I brought the wire up and I put it through a window. Now I don't like doing that because if you roll the window up and that cable gets caught in the window channel, the cable is ruined. It will definitely break the cable. So if you take it in through a window, make positive that you don't roll the window all the way up on the cable, because the cable will be ruined. The door jambs work really well. I prefer to do it like this, but here I've done it both ways to show you. So I've got this one in the same position. The sensor always is orientated the same as the other side, and it is. We're going to bring the cable, take it out, tape it to the body. Here we got the right rear, and I just attach this to the shock mount and it'll work fine. And then we just put the cable on here with magnets, and then we tape it up at the body like I've showed you. Here we've got the left rear attached, and notice it's in the same orientation. Always keep the sensors in the same orientation as the other side, and then take the cable and put the magnets down as you put it in. Just make sure you tape it to the body so the cable stays secured. Okay, so now we need to set up the IVA. So we're going to come over to setup. First thing I want to do is I want to look at all my sensors down here. So this is the box. When we want to record the data when we're out on the ride, we push the record button. But for right now, I just want to plug each sensor in. Make sure it's yellow to yellow, red to red, green to green, and blue to blue. Make sure that these are in the right places or it'll show the vibration coming from the wrong point. Do you see how that light's green? So that sensor is good. Want to put the red to red, and we can see it turned green. So we just want to go through all of these. Green to green. Make positive that these are pushed all the way down too, on the sensor and on the interface. And this interface is the scope and the OBD2 scan tool data. It's all built into one on my design. Okay, so now we have all the lights, so the sensors are all good. We want to set front wheel drive, vibration 4. We're looking at all 4 wheels, wheels and suspension. Now if we pick wheels and suspension, it'll look at engine vibration, tranny, front. It'll look at everything if I have wheels and suspension selected. Now we have to put in our tire size. So that's 215. 50. But so once you hit yes, it'll fill all the information out for you and will give you the tire circumference. Now make sure that if you have a worn tire that you actually measure the diameter. If it's way worn, we need to know that because this is calculating the rotational speed of that tire. The next thing that we have to know is the ring and pinion. Now ring and pinions on a lot of cars are really hard to figure out which one it is. Sometimes you have to get a VIN number and call in to figure out which ring and pinion you have. In this tool, I've designed some algorithms, some math, where I can automatically calculate it. So you just ask it to calculate it, and now we're going to need to get on the highway, and I need to go 60 miles an hour, and it will automatically calculate and fill this in, and then we can do the testing. But the ring and pinion ratio has to be filled in for this tool to work correctly. This whole tool is about math and mathematics. And all these speeds, we're calculating speeds to figure out what's vibrating. So let's go ahead and get on the highway and let this automatically figure it out for us. Okay guys, we're on the highway, and what we need to do is go till it turns green, and we need to hold it at that speed. Now we're running some calculations to calculate what that ring and pinion has to be. Okay, so we've calculated it now, it's right here. So now we're going to be ready to test this. So there's a piece of highway up here, or this highway has been repaved. So we're going to start to run the testing on some nice clean pavement. It's always best to be on smoother roads. You'll find the vibration irregardless, but it's always best on a smooth road rather than a rough road. This highway down here is pretty beat up still. That's why they've just repaved it, because it's been just ripped to shreds. Okay, so we're going to start the program. Now that we've got the machine working, I want to go ahead and I want to set the sensitivity. It's not vibrating, and I'm going about 55 right now, and it doesn't do it apparently till 60. So I'm going to go ahead and I'm going to raise the sensitivity. Okay, so I'm in the power right now, and it's shaking bad. As we can see, every wheel sensor is picking up that vibration. But notice we're automatically calculating for you which one is the worst, which one it's coming from. That's this one right here. And that is the right front is where my vibration is. I'm going to get into the power a little bit. Okay, this is a power related problem. As I put power on it, it gets way worse. I'm going to get out of the power and I'm going to let the car just float now. Where I'm not totally out of the power, I'm still in it, but I'm going to go just easier. And I can feel the vibration, but it's not nearly as bad. Now I'm going to give it some power. It's really, really shaking right there. As I get into it, this is power related, so torque is changing it. Always remember, guys, that you drive a car with a vibration in multiple modes. One, you get it under power and you see if it changes the vibration. And two, you sort of just let the car float. You get in minimum power. You just hold a little power on it and you see what it does. And we can clearly see the machine is already showing us that the vibration is on the right side, right front. So now I'm going to get into the power just a little bit. Yeah, it's shaking right there. I can feel it. Yeah, as soon as I start to give this car power, it really starts to shake. So I'm going right at 60. That's where this vibration is supposed to be. And it definitely seems to be that way. And I can feel the vibration, but it's not really bad right now. But if I give it any gas, now that vibration got heavy. So if I give it, I'm giving it gas, I can feel it, it's vibrating. I get out of it, I'm coasting now. And I can still feel it, but it's not very noticeable. Very light vibration when I get out of it totally. Now I'm just going to float the car. So I'm in the gas really light, and I don't feel it as much. I'm going to get in it, and now I've got way more vibration there. And again, we can see that it's coming from the right front. Want to go a little bit faster like we did just to see what's happening. Now I can feel, when I go faster, I can feel that vibration even if I'm just floating it. If I'm down around 50 or 60, I've got to be in the power to get it to, so I can feel it. If I got up towards 70 and 80, I could feel it totally floating the car. So I don't feel it very much there, but if I get in it, I feel it now. Definitely is vibrating. We're going to go just a little bit faster. Now I can feel that vibration. So I can feel that vibration now, and I'm just floating the car at 80. But definitely can feel that vibration. Can feel that vibration, and you can see where the algorithm over here is indicating which wheel it's coming from. As you can see, when it starts to vibrate, I'm going to get in it. All the sensors will show that I've got a vibration going on. So I'm going to give it some power. I can feel it shaking. We can see that we've got multiple sensors showing the vibration. And we already know that. I can feel the vibration in the steering wheel, in my pedals, in my seat. This whole car is vibrating when this vibration starts, like all vibrations. That vibration is taken throughout the car. You got to have multiple sensors on the car in order to know where it's coming from. Otherwise, it's just everything vibrates. It's hard to know where it's coming from. Okay guys, we can clearly see that we've got a vibration on this car. We need to go back to the shop and move the sensors around so we can isolate exactly what's vibrating now. Okay, so I've moved the sensors, so let me show you how I moved them. I moved the left front to the transmission case. Now this case is aluminum, so I use the clamp, and this clamp will allow the magnet to be put directly on an aluminum case. So that's on the aluminum case. Now this has got a two-piece axle on this side, so I took the left rear and I moved it forward, and this steel band that goes around the bearing is metal, so the magnet will hold directly to this. So I've just got this right to this piece here. And then this is on the out, the same right front I didn't move, I just left it here. So now I have one on here, one on the axle center, and one on the tranny. So now is what I'm trying to figure out, is where the vibration is actually being emitted from, so we can properly diagnose this car. No more parts. A lot of parts have been put on this car so far. We're going to fix this with the right part, the one that's causing the vibration. So let's go for a test drive and see what we've got. Okay, so we left the setup in four-wheel mode, just like we had it. The outer wheel has definitely got more vibration than the transmission or the axle. We can see that clearly. So that vibration is coming from the outside. Now the green one is on the axle at the support bearing, and this is at the transmission. I'm going to give it some power. You can feel it vibrate when I give it power. I'm going to get out of it. We're just going to coast a little and see what I can still feel the vibration. It's not as bad. I'm going to give it a little power. I can feel the vibration fairly heavy right there. So I got a light vibration there. That vibration appears to be coming from the outside axle, and we can see that the axle support has some vibration right there as well. But it's mainly coming from the outer sensor that's on the lower arm. So it's not coming from the transmission. That would be on the left front, because I moved that on the tranny and I don't see it at all. We're going to get in it here. We should vibrate. Vibrating pretty good right there. Again, I can see it's the axle and the axle support, but mainly it's coming from the whole arm. We're on the right front is on the lower arm, so it's coming from the outer assembly. Okay guys, this is the sensor that's vibrating. Now that's all the way out on the outer joint. Now this axle comes up and it's got an inner joint and a piece right here, a bearing, a support bearing that goes to the tranny. Now if that inner joint, this joint was the problem, I would have gotten more vibration on this sensor, and I don't have that. And if something was wrong in the diff, this would be the one that I got my vibration on. But my vibration is coming from this outer one. So it's something to do with this outer axle, this outer CV. But these axles have already been replaced, and this inner stub has been replaced. Okay guys, the first thing I want to do on this car is I want to make sure this wheel is centered on the hub. Some wheels center by the lug nuts, and some of them actually have a center ring to where the hub centers the wheel. But I've seen these not center correctly, and they align perfectly on a machine, it'll show that it spins, and it's true, but on the car it's not. In order to do this, because I got tread here, I had to take and put tape. So I took the blue tape that comes in the kit and I wrapped it around the tires, 2 wraps around the tire. And now I'm going to go around and I'm going to look at the run out. And this will give me a good idea if the tire could cause the problem. But I've never seen a tire create a problem with torque like this is doing. This has something to do with that axle, I believe. But I always want to start here, and we're going to work our way in with the dial indicator. But we can see that the tire is round. It's okay. This tire is okay. It's round. And it's centered. So now we've proven that it's centered to the hub and the tire is round. So that's vital. That's my first step. Now let's move that dial indicator and check that axle. Okay, so I put a jack under the front arm so I could raise the arm so that CV is sitting in its natural position like we are when we're driving down the road. I want everything as close to normal as we can have. Okay guys, I've adjusted the dial indicator on the machine section on that outer CV. Now, okay guys, so right here, we're going to check the run out on the joint itself. I want to make sure that the joint doesn't have a bunch of play or it's turning centered in the hub. So we're trying to just make sure that that CV joint is centered in the hub. And we can see that it's pretty good. A few thousandths of run out. That's pretty centered. I've had one car that I did where the bearing was actually, the center of the bearing was not in the center of the bearing. So the axle was actually going up and down because the hole in the bearing wasn't centered. Really an unusual car, but it taught me a lesson and now I know I need to check that. So this is a really good way to check to make sure that the CV is centered in the hub. Okay, so I got the dial indicator on the axle. Let's go ahead and rotate that axle and see what we've got. Okay, that axle is moving a lot, guys. Go ahead and roll it. Look at that axle move. Okay, we have a problem there. That's something that's not good. So let's look at this. Okay, look at all that play where that axle goes to the axle stub. Do you see that play? Well, I think that's the vibration right there. And that's a Acura. The stub, I think the axle isn't fitting that stub correctly. See that thing wiggle? And we can see the axle move when we're rotating with dial indicator. That inner axle has got a problem, and I think it's moving the whole axle, and the axle spinning not true. And when the axle spins not true, it's shaking the whole hub. Okay guys, we're back over at the shop and they've replaced the axle on this little Acura and they've been driving it. And the shop says that when he put the axle in, there's no play in the axle, and when they drove it, there's no vibration. Now I want to put the vibration analyzer back on the car and we're going to go drive it to see what it shows us. So let me get this thing up on a lift and let's check that axle for run out. Let's put the vibration analyzer on it. Let's get that done. Okay, we have the new axle in this vehicle and I've got this arm raised so it neutralizes it on the stand, just like I did before. So now let's look at how much it moves. Let's go ahead and roll it. Yeah, that axle's way, way better than it was before. Okay, I'm going to shake the CV joint here. I'm going to try to move it. We can see that that is way, way tighter. So that CV splines much, much tighter on the axle stub. And this axle stub has been replaced. And it's good. It's from Acura. This axle stub is from Acura. Okay, we're going to go on our test drive to make sure that this vehicle's fixed. I know my ring and pinion because we found it last time. It's a 456. So we're going to go ahead and select it so we're ready to go. Okay guys, we're back out. We're on the smooth highway. I'm at 60 miles an hour. I'm going to floor it. Oh yeah, no vibration at all. Okay, before I'd be shaking the car so bad right now it's not even funny. I'm going to slow down again to 60 and give a hard acceleration. We're at 60. I'm wide open. No vibration at all. This car is fixed, guys. We're going to go back to the shop now. Okay, we're right off of our test drive and this little Acura is fixed. It's definitely fixed. Now, is this one crazy Acura or what? I mean, can you imagine if the shop's working on a car like this? You replace all of the tires, and guys, the tire shop that did the tires on this car, they're the best tire shop in our city. They are good technicians. And then it goes to the dealer and they put the little stub in there and then somebody puts axles in it. By the time you get it, what's wrong with it? Well, it's pretty hard to say it's an axle or the stub. They're brand new parts. It must be the transaxle. The owner of this vehicle brought it to this shop and told him the transaxle had the vibration in it. And this shop, thank God, he's a really good shop. And he knows not to just replace the only piece that hasn't been installed. So he called me, I came over, we threw an NVH on here, a multi-sensor NVH, because that's the only way you're going to find a problem like this is with multi-sensor NVH. Can you imagine if you didn't have that? What are you going to replace next? It really gets confusing. But when you have a multi-sensor NVH and it shows you exactly where the vibration is being emitted, well then it's easy, guys. You take your magnifying glass and you look right there and you can find it. And you too will have good troubleshooting in your bays if you have a multi-sensor NVH. You guys have good troubleshooting in your bays.